Sentry, a fully autonomous underwater vehicle, nearly the size of a small car, is designed and operated by the National Deep Submergence Facility at the Woods Hole Oceanographic Institution. Since becoming operational in 2008, Sentry has been utilized by numerous ocean scientists from institutions across the United States and around the world, as well as other organizations including federal agencies, corporations, foreign governments, and philanthropic organizations. Sentry is a part of the National Deep Submergence Facility, a joint venture between NSF, NOAA, and the Office of Naval Research. NDSF provides easy access to the deep ocean for scientists with a negotiated federal day rate for assets such as Sentry. In addition to its primary role as a tool for scientific investigation and exploration, Sentry is often applied when researching problems of societal importance. The 2010 Deepwater Horizon oil spill in the Gulf of Mexico required swift action to determine how and where the oil had spread, not just on the surface of the water, but also beneath. Multiple surveys were performed by Sentry to track and locate subsea hydrocarbon plumes and to obtain maps and images of deep-sea biological communities for follow-up observations. In April of 2016, Sentry participated in the search for the missing data recorder of the sunken cargo ship El Faro in more than 15,000 feet of water. The information recovered from the missing data recorder and the detailed maps created of the wreck site have provided investigators with additional tools for their analysis into why and how the ship sank.
There's an extremely broad range of applications of AUVs, anything from finding a lost object, such as the El Faro voyage data recorder or the missing Air France flight, but more typically it would be something along the lines of studying an area of the seafloor, at least the way that we work in our primarily science endeavors.
Sentry is a flyaway system that can be transported around the world and installed and deployed from multiple ships of opportunity.
Sentry packs into two 20-foot containers and moves by land, sea, or even commercial air cargo. We can mobilize onto that ship very fast, typically in 2 to 3 days, and then be ready to conduct science operations. We have invested an enormous amount of engineering design effort in optimizing Sentry's ability to work in the water at the same time as other assets.
Sentry is designed to work alone or in close coordination with other scientific instruments. Sentry routinely conducts simultaneous operations with ROVs, CTDs, dredges, net samplers, coring systems, towed cameras, and others. This significantly increases the efficiency of ship use and can provide a more synoptic view of the study area.
Many of the most interesting areas of the seafloor are actually quite rugged areas. They involve volcanic features or seamounts or canyons that are very difficult for a conventional AUV to operate in. And what that means is that if you want to collect your data very close to the seafloor in there, especially for things like images, you need a very novel approach to your AUV, and that's what Sentry provides.
Sentry has a unique shape. The double hydrofoil body allows Sentry to move efficiently, both vertically and horizontally through the water with a very high degree of inherent roll stability. Sentry's articulated wings allow the vehicle to fly over the seafloor while maintaining a controlled speed of up to 2 knots. This design allows Sentry to effectively survey steep terrain and near-bottom environments for extended lengths of time. The high stability of the vehicle improves sonar performance, which results in better data products.
Sentry collects a wide variety of standard data products. Probably one of the most common is our bathymetric maps, which we make with our multi-beam sonar. We can vary the resolution and the coverage rate with a maximum resolution of about 30 centimeters. Once we recover Sentry, we have highly automated processing software which will typically provide you with a first-pass map in less than an hour. Sentry has 3 different side-scan sonars that it can utilize with resolutions that range from a couple of meters at a very wide coverage rate down to about 10 centimeters at a lesser coverage rate. Side-scan sonar data can then be mosaicked to present an acoustic image of the seafloor that shows things like hardness and rugosity. We collect sub-bottom sonar data, which is a chirp profiler. It's able to actually see the different layers of the sediments and bounces off of rock quite nicely so that we can actually see the depth of the sediment over the top of the rock. We carry standard 3 3-axis magnetometers, which are actually set apart on a approximately 1 meter baseline in a triangle configuration, which allows you to do gradiometry measurements as well. Another very common data product for Sentry are high-resolution digital still photos. Sentry's camera is 11.4 megapixels with a very high dynamic range and a lot of light, which means that you can zoom in on the photos, sometimes for enough detail to actually identify species. Each image has about a 5 meter by 5 meter field of view, which gives you both a fair bit of view of the seafloor and also allows us to fly with significant overlap, which allows for later mosaicing of the photos into a single large image. As well, we carry a number of different chemical sensors, including a dissolved oxygen sensor and a oxidation reduction potential sensor. We also carry some physical oceanographic sensors like a turbidity sensor and a conductivity temperature depth sensor. And together, those give you a pretty synoptic view of the water you're flying through. And if you do need more information, we do routinely integrate things like fluorometers or other chemical sensing devices.
Sentry can be described as a turnkey system for all users. Specific project guidance is provided for every step of mission planning, including efficient sensor use and survey design. To support Sentry's usability, all programming for the vehicle is generated and executed by an engineer from Sentry's team, so users can focus on science. Sentry's rapid data processing system allows for both raw and preliminary data to be received, typically within 90 minutes of mission and recovery. Photos typically require additional time. Rapid generation of preliminary products enables informed decision-making on use of other assets and future missions. Additional data processing may sometimes be needed for publication-ready graphics. Sentry is designed to easily incorporate custom payloads. This allows users to either utilize the standard sensors that NDSF provides or bring their own sensors that can be inexpensively integrated by Sentry's experienced engineers and technicians. Past special applications include mass spectrometers to detect minute chemical compounds, sampling systems to collect plankton or trace metals in the water column, and special imaging sensors like a stereo imaging reconstruction system that generates centrometrically accurate 3D models of the seafloor.
We are constantly engineering new systems and upgrading the systems on Sentry. And we've done that in a variety of ways, everything from better flight control systems to better user interfaces, better mission planning, more sophisticated missions that can be flown, as well as new sensors and new samplers. We have a whole bunch of new ideas that are also in the pipeline. Everything from autonomous surface vehicles that might follow the vehicle around on the surface and allow the ship to go away for days at a time, to anchoring systems that would allow Sentry to wait on the seafloor until the ship comes back and is ready for it, to very advanced communication technologies that would actually allow the user to know a great deal about what is going on the seafloor before the vehicle is recovered and therefore be able to reprogram the mission in real time to take better advantage of what's going on.
In this period of rapid technology development, the NDSF and Sentry strive to make the engineering aspects of underwater survey as simple as possible for users. When engineering and technology burdens are lifted, focus can be placed on science first, doors become open, and novel approaches to scientific questions become possible. The NDSF website contains a variety of resources to help you understand how best to use Sentry for your scientific needs. NDSF staff can help you understand the vehicle, craft your operations plan, and make sure your proposals are successful.